Calculus! AP Calculus! 6-3. Specific, particular solutions. So today's lesson is an extension of yesterday's lesson. Yesterday's lesson we were talking about just those first 3 steps. Today I'm talking about that missing step, step 4. The homework tonight, by the way, since this is technically an optional lesson, is doing the same thing that you did yesterday, but with an evaluation step in each problem. But you can also add the isolate step to each problem if you want to practice it. I am definitely practicing it myself, although the homework is definitely not near as hard as the AP exam. I chose 2 previous AP exam questions to see how hard it actually is, so you can get some practice. So let's assume that you want to do step 4, to isolate. To isolate just is a fancy way of saying get that y by itself. Whoa. Get, and my pen width has been changed by 0.5. There we go. So this is get y by itself. So there are essentially 3 steps when you're working on step 4 for isolate. So the first one is to find C using initial conditions. This heavily overlaps with step 3. Do you remember step 3? What was it called? We had separate, integrate. What was step 3?
Plug in.
It was plug in, evaluate, yes.
Procrastinate.
That's not step 3, that's step 1. But
Yeah.
So yeah, you'll usually find that in your evaluate step. Hopefully it doesn't mess you up too much. And then you need to, for part B, to plug that C in. Plug C into original equation. Yeah, what's up? Yep. And then the last step is to isolate y. But finding that C, if I could, I guess I should have given a star, but if I could give anything a star, it's finding that C. That C is really, really hard to find on the actual AP exam, which is why isolate doesn't really happen. Usually you just plug in the initial conditions as if you're trying to find C, you get the points for it, and then move on. But that first thing, finding C, is super hard. Let's see why. This one is a little bit easier. This one, Pandora's box, I'm giving it my own name since John gave cutesy names. It's my cutesy name. Pandora's box is really, really hard, and those are typically on the AP exam. This one sometimes is on the exam. These are on the older exams at least. All right, so finding the particular solution. Whenever you see particular solution, you need to be thinking of doing this procedure of isolate, or sorry, not isolate, of what were our 4 steps? Can you guys help me out? First step was to, starts with an S. Separate, yes. So here I go. I'm on step 1, separate. What's step 2?
Differentiate.
Yeah, you're going backwards. You're going forwards. Differentiate is going forwards. It's going backwards. Anti-differentiate, which is just with an I. Integrate. There it is. Step 3 is to. I'll help you. Step 3 is to evaluate, and step 3 is to, or step 4 is to. Sorry. Last step. That's optional.
find C. No.
God. It's isolate. So separate, integrate, evaluate, separate, or sorry, isolate. I got separate twice. We'll get these down. All right, so I'm separating. What do I do when I separate? You're doing this work for me. This is a review. First, I need a fraction equal to a fraction, so I have this over 1. And then I do what?
How dy equals xy to the 3rd dx.
dy equals xy to the power of 3 dx. Yep. And you're doing cross multiplication to get there. Sounds good. We have 1 dy, which is where that dy came from. That was separate. Let's do step 2. And I'm going to do it to the right because we're going to need the bottom area to do a lot of math. Separate. Step 2 is to step 1 was separate. Step 2 is to integrate. So I have the integral of dy on the left, is equal to the integral of,
But you want to get
Oh.
y?
I totally forgot to, yeah, sorry. What do we need to do? Let's give it an arrow since Ben just did the last part.
Divide by y to the third.
Yeah, so we have, sorry about that. I don't know why I'm just skipping steps randomly. 1 over y to the third dy is equal to x dx. Which means if I come back here and get rid of this, always does that. Just messes up. Scroll down and scroll back up and it fixes it. Okay, so now I have this integral of, I'm just going to immediately change it. I don't like fractions, so 1 over y to the third is what with a negative power?
Y to the third. Y to the negative third.
Y to the negative third dy, and that's equal to x dx. Perfect. Write that down. All right, let's go ahead and actually do the antiderivative. Let's integrate. So y to the negative third, antiderivative is?
Negative 1/2 y to negative 2.
Yeah. So it goes y to the negative 2 because it goes up a power and then divide by that negative 2. So divide by negative 2, which is where that negative 1/2 comes from. And that's going to be equal to arrow. What's the antiderivative of x?
X squared over 2.
Yep. And what are we forgetting?
Plus c.
Plus c. Just by adding that plus c, you get a whole point just by doing that. That's why it's super important to remember.
Forget.
It is easy to forget. Remember your plus c. That's a whole point. That can be the difference between you getting a 3 or a 4. All right, so we have the plus c, that's integrate, and let's do step 3, which is to evaluate, or I should have asked that, but evaluate. And when I evaluate, I'm plugging things in. So what is my x and what is my y, according to my problem?
X is 1 and y is 2.
X is 1 and y is 2. So we'll just write those above them. All right, so let's go ahead and plug those in. Again, I don't really like plugging into something with a negative power, so I'm going to rewrite this as 1 over y squared, or negative 2y squared, so negative 2, there's my y squared. And that's going to be equal to, there's my x, I can give more room, there's my x squared over 2 plus c, and then when I plug in my y is 2, I said, and my x is 1. And then I just need to simplify this. So simplified, that turns into what? Two to the power of 2, shout it out. 4 times negative 2, close.
This is wrong. Negative 8.
Yeah, negative 8. So 1 over negative 8 is equal to what? 1/2 plus c. Therefore, c, so therefore, c is equal to
Negative 5/8.
-5/8. All right, that was evaluate. And that was already doing part of step 4, which is to get c using the initial conditions. And this one wasn't that hard, but let's go ahead and rewrite this problem correctly. All right, so we're on step 4. Step 4 again was what?
Why do they have fancy names? They're easier to remember without the fancy names.
Okay, well, we're isolating. We're doing that final step. You don't like the names, that's fine. All right, so what do we do?
Isolate y. Get y by itself.
Yeah, isolate y, get y by itself. So we're looking at this equation right here. And we're trying to get y by itself. So I need to get rid of that negative 2. I'm going to multiply everything by negative 2. And that c is obviously changed to a negative 5/8. So I now have y to the negative 2. I got rid of the negative 2 on the bottom, and I multiplied it over here. So it's going to be a negative x squared. And then I had negative 5/8, but I multiplied negative 5/8 by negative 2. So I now have plus 10/8. Can we follow that? So far, so good. Okay.
No, wasn't it 1.5 y to the negative
Yeah, you're over negative 2 right there. Is that what you're talking about?
Yeah.
Yeah, and then we multiplied everything by, oh, did I forget the 2 right here? No, I didn't. Okay, so the 2 and 2 would cancel each other out, and it is just left with a negative.
I just missed that step.
No, you're good. I'm skipping steps, and maybe I shouldn't be doing that.
For y when we already know y.
We- So the whole point of find the particular solution is find the equation. Y equals what?
Oh.
So that's what we're doing right now. We're finally getting y by itself.
Now we have the interception.
Yep. All right, so I'm going to rewrite this equation. I'm going to rewrite this, and I'm just going to go down here because I think we're going to come back up once we run out of room. So y to the negative 2 is the same thing as 1 over y squared. So 1 over y squared is equal to negative x squared plus 5 over 4. Just simplify the fraction, rewrote this without a negative power. So the problem here is, again, I have something in the denominator, which means whenever I have something in the denominator, I need to cross multiply. So this whole thing, right, over 1, and then cross multiply it. 1 times 1, and this y squared, like that. And another way of doing this, and here's the trick, is you just take the reciprocal of both sides. So if this is over 1, take the reciprocal of the left, switch these two, take the reciprocal on the right, switch these two. That is a valid mathematical operation, which means now I'm left with, I should be switching colors so I can see what's going on. Now I'm left with y squared over 1, which is just y squared, is equal to 1 over all of this stuff, negative x squared plus 5/4. So far, so good? All right, now we ran out of room, so we're going to come back up here to the top. Last step is to, well, I guess it's not our last step because there's a hidden last step that it makes this a tricky question. I need to get y by itself, so I'm going to, yeah, square root both sides. So let's do that in black. Square root that, and I'm left with y by itself. And whenever you square root, you always have to write the plus or minus, yeah, plus or minus. Plus or minus, and it's going to be 1 over negative x squared plus 5/4, and then all of that is going to be square rooted. All right, so there's actually a hidden step. If you just wrote this, you wouldn't get the full 1 point, or maybe 2 points. I know, it's sad, and that's why maybe you don't want to do this. This is optional.
So you would do that and still have gotten 0 points for doing it?
Yeah.
So what do you have to do?
So now we have to check which one of these. It's either one or the other. It's never both.
No.
Never both.
This is
Really?
gonna
Yep.
be very long and terrible.
Yep.
Okay.
So in order to check, you need to plug in the initial conditions. So let's do a note here. Note. You need to check whether it's positive or negative. It can't be both. It will never be both. At least, and I've taken the AP test so many times now, and it's never been both. So I'm just assuming it's never been both. It will never be both in the future. So I'm going to check using the initial conditions. So I'm plugging in for y. What was my y? You remember all the way from the very beginning? Yeah, y was 2. So I'm plugging in my 2. And that was equal to, and then we'll leave it plus or minus for now. It's going to be one or the other. It'll make sense in a sec. Square root, and technically you're only doing the square root of the bottom because square root of 1 is 1. So I'm just going to do 1 over the square root of all this stuff. I have my negative x squared plus 5/4. And my x, I told myself x was 1 for my problem. All right, so now I need to simplify the inside here. So negative, or 1 squared is just 1, negative 1. So I need to combine negative 1 with positive 5/4, and this problem now becomes what? Yeah, it's positive 1/4. 1 over 1/4. Square root of 1/4, I should say. We saw that square root, right?
Yeah.
Then you see the 1/4?
Yeah.
Yeah, because this is the same thing as writing negative 4 over 4. So I'll make that note. in case someone can't see that. This thing right here is the same thing as negative 4 over 4. And 5 minus 4 is just 1. Okay, square root of 1/4 is 1/2. So this thing is, we can rewrite this as, we're running out of room, so let me do it right here. This thing evaluates to 1/2 because you take the square root of the top, which is 1, square root of the bottom, which is 2. So now we have the equation 2 is equal to plus or minus 1 over 1/2. And do you remember what happens when you have mixed fractions? Fractions over fractions? What happens is this 2 can jump 2 spaces, which means it just comes up here to the very top, which means 2 is equal to plus or minus 2. So this problem now becomes, I ran out of room, even though I gave myself all of that room. Geez, I need to be more conservative about my room. That means 2 is equal to plus or minus 2. We'll be more conservative for the next problem because that's even a bigger problem. All right, so which one was it? Was it plus or was it minus?
Plus.
It was plus. So go back up here to your original answer and go ahead and cross out that minus. It was plus. Now you get your full 1 point. Even though you've gotten 6 points by doing those first few steps from yesterday.
So you just circle the plus sign?
Well, I mean, technically you would rewrite it, but we ran out of room. Your full answer is y, and let me see if I can rewrite this nice and tiny down here. Your full answer is y is equal to positive 1 over the square root of negative x squared plus 5/4. That's square rooted. That is your final answer. Box it. You actually found a final answer, which is very, very hard to find.
It's not 5 Anyway.
Yeah, it's the same thing, but yeah, down here with a positive. Whew. All right, let's do a Pandora's box example. This is even harder, in my opinion. All right, Pandora's box. Find that particular solution to this equation. Let's see if we can be more conservative about our space. So let's do step 1, which is to separate. I'm just going to do 1 instead of writing out the word separate because it seems like we don't really like that. When I separate, what is my equation? I have dy on the left because that's over 1. 1 times dy is dy. And on the right, I have
So dy equals 3 minus y times cosine x dx.
there it is. And trying to get the y on the left-hand side means I'm going to have what?
Divide by 3 minus y.
Yep, so I'll have 1 over 3 minus y on the left. dy is equal to cosine of x dx. All right, that was step 1. Let's do, I think I'm just going to go straight down. I think that makes a little bit more sense. And then once we have room, then maybe we can use the whole right side to do step 4. Step 2. Step 2 is to integrate. So I'm now going to integrate, and I'm going to rewrite that left-hand side without a fraction. So that's going to be 3 minus y to the power of negative 1. So 3 minus y to the power of negative 1. Keep my parentheses, to the power of negative 1 dy. And that's going to be equal to the integral of cosine of x dx. Okay, when I take the antiderivative, I am going to have what on the left-hand side?
Taxman.
It is going to be taxman, yep.
It's going to be negative 1.
So taxman, you're paying taxman with negative 1. So this is now the integral of negative 1 times 3 minus y to the negative 1 dy. We just paid taxman. We skipped all those steps. If you want to see those steps, I can write them really quickly off to the side. We knew that our u was 3 minus y. We know that taxman, there's no one, so it's just 1. And then u prime was negative 1. So I'm paying taxman with negative 1. That's why Ben paid negative 1. So we've paid taxman, which means when I take the antiderivative now, I get what?
Negative ln negative y plus 3.
Negative natural log 3 minus y. Did you say absolute value?
Yeah.
Okay.
That's the value.
Good. That's the left-hand
always
side.
forget that.
Yeah, this one definitely needs absolute value. That's the reason that this one is so hard, is to get rid of that absolute value. Again, the reason that we need absolute value here is because we need to make sure that whatever we're plugging in here for natural log is positive, and it's possible that I chose 10 for y, which means I'll have 3 minus 10, which is negative 7. Absolute value of negative 7, make sure that we're in the domain of natural log. If I plug in negative 7 in natural log, you'll see that you'll get an error on your computer or on your calculator, whatever you're using. All right, so, and take the antiderivative of cosine. It's anti-change, which means it's the same sign. Sine of x, there it is. And yeah, don't forget your plus c because you need to get that point. All right, we're doing really, really good so far. We've gotten almost the half the points for this question just by doing those few steps. I'm definitely getting that plus c in there. All right, now I need to start solving this guy. So how do I could plug in and evaluate. The problem with just evaluating is it doesn't take into account with these absolute value signs. So that's why I said yesterday that if you just do step 3 to evaluate, to plug in those numbers, it's going to mess you up because C might be that positive value, but it might be the negative value. You don't know exactly what value it's going to be. So we can't do step 3 yet. We can't just plug in and evaluate. Although if you want the 6 out of the 9 points, just evaluate and you get those 6 out of 9 points, you're good, you'll get the 5. To do this whole problem, this is what you need to do. Solve for y. And that's what we were talking about at the very front. So we're going to find C using initial conditions if you can, and to do that, we're going to solve for y. We're going to isolate y right from the get-go. So let's try to isolate y. Well, first let's get rid of this this negative. So by getting rid of the negative, I now have natural logarithm of absolute value of 3 minus y and absolute value. That's going to be equal to negative sine of x minus c. How do I get rid of natural log? This is something that I didn't really cover in. It is e, yeah. Do you remember? The technical word is exponentiate, which is a fancy way of saying do e to the power of this and e to the power of this. So the way that you do that, I'm just going to write it down here. It's going to be e to the power of natural logarithm of absolute value of 3 minus y is equal to e to the power of negative sine of x minus c. This process, I'm going to write this on the side notes, this process that we just did right here is called exponentiate. Exponentiate. We exponentiated both sides. And by doing that, the e and natural log cancel out, and I'm just left with absolute value of 3 minus y. So technically, right now we are doing step 4. We're doing step 4 right now. So absolute value of 3 minus y is equal to e to the power of negative sine of x minus c. So far so good. We're okay with exponentiation? Okay.
Wait, how did you get there? How did you get rid of the first e?
So e and natural log, they cancel each other out, and I'm just left with absolute value of 3 minus y in the base.
Oh, right.
Yeah, the whole point of trying to do e to the power is to cancel out. E to the natural log of whatever is whatever. That's just one of the rules of logarithms that we talked about. Was it algebra 2 or pre-calc? I think it was in pre-calc last year, right?
Probably, because I think we skipped algebra 2, so there's...
Oh, yeah, this makes sense.
Okay, so now we need to get rid of these absolute value signs. So that means, have you ever gotten rid of an absolute value sign before? Or I think we have, and we might not have remembered, but the way that you do that is you just drop them. You drop them, and you have 3 minus y is equal to, and then when you drop them, whatever is outside of that gets a plus or minus. So this is now going to be plus or minus e to the negative sine of x, and here's the cool part.
Oh, you can't make something negative.
You can't make something negative?
Well, e to a power is always going to be positive.
Yeah, you're right in terms of this thing is always going to be positive, but now we're saying it can be positive or negative. We can just add that. It can reflect over the x-axis. So don't write minus c in that power yet, because we're going to use another rule of exponents, which is to separate this. Again, we're not only trying to isolate y, but at the same time, we're trying to also get c by itself. Right now, c is trapped in this exponent. So what we can do is we can say, use rules of logarithms. I'm really going to be adding this negative c. So do you remember what adding means for powers when you're doing bases?
Oh, it's e to the negative sign of x times e to the negative c.
There it is, yeah. That's how you separate them. All right, we're almost to the part where we need Pandora's box. I think we're on that spot now. So Pandora's box, things that we can't really handle. We can't handle the fact that there's this e to the negative c, and we can't really handle the fact that there's a plus or minus. We need to somehow have some sort of box that includes all the things that we don't know, all of the unknown stuff, and just box it, and we'll treat it as just a single variable. And it's kind of weird to do that, but here we go. So I'm going to switch these two around because there's the multiplicative property of association. So I have this plus or minus e to the negative c times this e to the negative sign of x. I know what e to the negative sign of x. I can solve for that. I know that guy. So what I'm saying here is, maybe I should write this out as a separate step. I'm just going to switch these two. So I now have 3 minus y is equal to plus or minus e to the negative c times e to the negative sign of x. Look here. This right here, everything that we don't know is contained in that box. We know what y and x are because we have been given initial conditions. We know that x is 0 and y is 1. So the only thing that I don't know is all contained inside of this box, inside Pandora's box. So let's go ahead and finally isolate y using Pandora's box. From now on, instead of writing plus or minus e to the negative c, I'm just going to write box. So let's go ahead and isolate for y. Y is now equal to, well, I subtracted 3 from both sides, and then I multiplied everything by negative 1. I'm doing 2 steps at once. Can we handle that? So I subtracted 3, but then I multiplied by negative 1, so it's really adding 3. 3, and then since let's see here. So it's going to be 3, and then this was going to be plus, it was going to be a plus, box times e to the negative sign of x. But because we multiplied by a negative, this is no longer a plus, it's now a negative. So far, so good? Welcome back, Rochelle. We're doing a Pandora's box example, which is one of the hardest AP Calculus questions you will ever face on the AP Calculus exam. In my opinion, it is the hardest question I've ever seen on an AP Calculus exam. Hitting it right here in Unit 6. All right, so we have now isolated for y. We now need to solve for what that box is. What is this box? How are we going to do that? Any ideas? How are we going to solve for what that box is? What is Pandora's box?
Plus or minus e to the negative c.
Well, that's what is in there, but we can actually say what value this box is. We can say that box is 2 or something. How are we going to do that? Well, we have too many unknowns. We have an unknown there, we have an unknown there, we have an unknown there. Make box the only unknown. How do we put in something for x and y?
Just plug in the values.
Yeah, plug in your initial values all the way back up here. X is 0, y is 1. So here I go. Y is 1, so I'm plugging in 1, is equal to 3 minus box times e to the negative sign, and I'm plugging in 0.
Oh, and that works out because the sign of 0 is 0.
Sign of 0 is 0, so negative 0 is 0, so e to the 0 is 1. So this whole thing right here goes to 1. And 1 times anything is anything. So this all simplifies down to just 1 equals 3 minus box. Okay, well now I can find what box is equal to. Box is equal to what? Pandora's box is
Negative 2.
Careful.
Positive 2.
Positive 2, yeah. We didn't even know what was going on here. We had an e to the negative c, we had this plus or minus, but we know that everything right there happens to just be 2. By just condensing all of that unknown stuff into this one unknown spot, and solve for that one unknown spot. That unknown spot, that Pandora's box, happens to be 2. All right, we're done. We just need to rewrite our equation. Our final equation, y equals what? Again, that's what we're trying to solve for. When I ever ask for find the particular solution, it's really asking for y equals what with that initial condition, solving for c. Y equals, so you're rewriting all of this, but in the place of box, you're saying 2.
Oh, that's interesting.
So let's just rewrite it, 3 minus, and instead of box, it's 2. 2 times e to the negative sine of x. Done. Box it. That's your final answer. Did I box my final answer on my last page? I did. Whew, yeah. That was intense. And those are really, really hard. This is not in John's curriculum. This is something that I have just made up on my own and I have decided to teach. And again, I'm stressing this is optional. By doing all of this work, by spending, how many minutes did we do from step 4? Maybe 10 minutes. In 10 minutes, we got 1 point. If you did all of that correctly.
Wow.
Yeah, okay. So now you understand why I was talking so much about yesterday, gaming the system. That was really hard. That concludes the notes. Go ahead and write your summaries. Know that there's 2 examples that I've ever seen on the AP Calc test. There might be harder ones, but there's Pandora's box, and then there's the square root where you have to check the initial conditions to find if it's a positive or a negative. Make sure you know that those are the 2 possibilities for isolate that Mr. Sindel knows of. And the homework is just going to be doing steps 1 through 3 over and over. And if you choose to do step 4, that's your choice. It's totally optional. I am going to be making sure that the answer key has step 4 over and over again. All right, that concludes the notes.